Hi, everybody. Welcome back. If you're watching this, it's probably April 15th or somewhere thereabouts. I hope everyone's doing well. So, when you think about what we've been doing recently, we've been focusing on ionic compounds and specifically things like writing formulas for them, writing names, and doing formula mass. Remember, with the name and the formula, that's a way of simply identifying which elements are in a compound. So, for instance, sodium chloride, table salt, has sodium and chlorine, hence the formula NaCl and the name sodium chloride. Okay. The formula mass then tells you the mass in grams of 1 mole of the compound. Now, if you're sitting there thinking, yeah, why do we deal with formula mass? What's the deal there? Why? Right. The idea is that you can use formula mass to make predictions. For instance, if you have 500 grams of iron and you want to know if it rusts completely, how many grams of rust will it form? Rust is iron oxide, and you can use the formula mass of both iron and iron oxide to predict how much rust should form if that 500 grams of iron, which is about a pound of iron, were to rust completely. So that's the idea with formula mass. You can use it to make predictions, and eventually I'll have you do that. Okay. So that's formula mass. Now, today's piece, you're going to be looking at percent composition. Okay. Basically, given a compound, a formula, what percent of that is made of its different parts. So, for instance, here's a seashell, fragment of a seashell. Looks pretty cool there, side view, right? Yeah, I'm sure if you've gone to the beach, you've picked these up, like, oh, look at that shell. It's so awesome. So there you go. Now, seashells are largely calcium carbonate. This stuff here, which is a combination of calcium, carbon, and oxygen. Calcium is our cation here, our metal. Carbonate, CO3, is the anion. And remember, CO3 is one of our polyatomic ions, which are listed on the back of your periodic table. So this shell is largely made of this stuff, calcium carbonate. So you could ask, what percent of the shell is calcium, what percent of it is carbon, and what percent of it is oxygen? That's the idea with percent composition. Okay. Given a compound, whatever it is, and it could be an ionic compound, it could also be a molecule. Okay, and you'll see some of those too. What percent of the substance is made of its different parts? Okay, so what you're going to do here, you're going to watch the remainder of the video, which will show you exactly how to calculate percent composition. Okay, after that, there's a practice worksheet that's a Google Doc. You should do it. In the next lesson, the answer key for it will be attached. In the next lesson, there will also be a Moodle assignment, which is going to be based on accuracy on percent composition. Okay, everybody. So that's the idea. Shell, percent composition. What part of this is made of different elements in the compound? Do your best, of course. If you have any questions, let me know. Thanks a lot. All right, I'll see you later. Once you know the formula mass of a compound, you can then figure out the percent composition of that compound. Remember that when you do a percentage, anytime you do a percentage, it's part divided by the whole times 100. For instance, if I have 8 slices of pizza, 8 slices, and I eat 4 of those, 4 divided by 8 times 100, that's 50% of my pizza that I've just eaten. It's a lot of pizza. For chemical compounds, again, if we pick the compound apart element by element, or piece by piece, we can determine the percent composition of each element in the compound. Another way of saying that is what percent of the compound, by mass, is made of its different parts. And to do this, we need to know the formula and the formula mass. Now, when you do percent composition, we'll start with calcium.
you need to know the calcium component of the compound. And we said in the previous video dealing with formula mass for calcium nitrate, we have 1 calcium, so that's 40.08. What we're going to do then is divide that by the formula mass of the compound. So 40.08 divided by 164.1, and then we will multiply that by 100. When we do that, we get 24.4%. So what we're saying here is that 24% of this compound is calcium by mass. Now for the other elements, let's do those. Nitrogen, remember that our nitrogen component was 28.02. That's 2 nitrogen atoms. And we're going to divide that again by the formula mass, 164.10. And then we will multiply that by 100. When we do that, our percentage is 17.1%. So what we're saying is that 17% of this compound by mass is nitrogen. Finally, for the oxygen, there we go, 96.00 was our oxygen portion. And again, we'll divide that by the formula mass of 164.10. Multiply that by 100, and when you do the math on that, we see that 58.5% of calcium nitrate is oxygen. So percent composition, the part divided by the whole times 100. The part being the mass of the single element or single component in the compound, and the whole being the formula mass of the compound, percent composition. Another thing that relates to this, keep in mind that when elements bond together and bond with other elements, they take on new properties. Nitrogen and oxygen in their pure form are gases in our atmosphere. But when they're bound together as nitrate, and when they're bonded with calcium as part of an ionic bond, they're now solid. And if you think about it, about 75% of this compound by mass is made of things that otherwise would be gas in our atmosphere in their pure form. Just something to think about. Percent composition.